Have you ever really thought about what makes a car go, a bike move, or even a clock tick? It's definitely not magic. It's this incredible hidden world of belts, chains, and gears. So today, we're going to pull back the curtain and uncover the secrets of these unsung heroes that literally power our world.
I mean, think about it. You turn the key in your car, the engine roars to life, but then what? How does all that noise and fury actually translate into the wheels turning and the car, well, moving? The answer is just a beautiful piece of engineering.
And that's where this concept comes in. Engineers, of course, have a name for it: mechanical power transmission. It's the art and science of taking raw energy from a source, like that engine, and delivering it right where the action needs to happen. You can almost think of it as the circulatory system for the entire machine world. So every single machine out there that has moving parts has to solve this exact same power problem. And engineers have come up with 3 really ingenious solutions to get it done. Let's break them down. And here's the really cool part. All of these different solutions fall into 2 main camps. First up, you've got frictional drives. These work by gripping, kind of like the brakes on your car. But there's a catch. They can slip. On the other hand, you have what are called positive drives. Now these are like interlocking puzzle pieces. They create a physical lock, so there's absolutely no slipping. And this difference is crucial, and it's something we're going to keep coming back to.
All right, let's start with our first solution, the true hero of frictional drives, the humble belt. This is the smooth, quiet operator of the power transmission world.
The idea here is just beautiful in its simplicity. You've got one pulley connected to the power source, that's the driving pulley, and another on the part you want to move. A flexible belt just loops around both of them, and through the magic of friction, when one pulley turns, it forces the other one to turn with it. Simple as that. But, like any hero, the belt has its weaknesses. Its superpowers? A really simple design, low cost, and super quiet operation. But its kryptonite is that very same friction. See, if the load gets too heavy, the belt can slip, and when it slips, it wastes energy and becomes less efficient. It also has to be kept under pretty high tension just to maintain its grip. And you've seen these belts in action absolutely everywhere, probably without even thinking about it. They're what's spinning the big cooling fans in buildings, moving your groceries along at the checkout, and even running essential parts of your car's engine, like the alternator.
Okay, but what if slipping is just not an option? What if even the tiniest amount of slip would be a total disaster? Well, that's when you call in our second hero, the tough, no-nonsense chain. This is the specialist of positive drives.
Now this is where the magic of the positive drive really shines. Instead of those smooth pulleys we saw with belts, we now have sprockets with teeth. The chain's interlocking links mesh perfectly with these teeth, and that creates a physical lock. There is zero room for slipping here. When one sprocket turns, the other one has absolutely no choice but to follow along. So, what's the chain's story? Well, it's an absolute powerhouse. It gives you a no-slip, highly efficient drive that can handle a ton of power. But it's not without its own quirks. All that metal-on-metal contact means it needs lubrication to stay happy. It can be a bit noisy, and it demands perfect alignment to work correctly. The most classic example has to be your bicycle, right? That chain is exactly what turns the power from your legs into forward motion. You'll also find them on motorcycles, all over heavy industrial machinery, and even deep inside high-performance car engines as timing chains, where perfect, synchronized movement is literally a matter of life or death for the engine.
Okay, let's just quickly nail this down. Belt drive, it's all about friction. It's quiet and cheap, but yeah, it can slip. Chain drive, it's a physical lock. It's powerful, efficient, and there is absolutely no slipping. That is the key takeaway.
And now, for our final contender. Let's meet the most precise of them all, the gear. When you need compact power and just pinpoint accuracy, the gear is always your go-to solution.
Gears are really a whole family of solutions, and each type has its own specialty. You've got the classic spur gear, which is perfect for connecting 2 parallel shafts. But what if you need to turn a corner with that power? Well, that's where the amazing bevel gear comes in, with its cone shape that can turn the motion a full 90 degrees.
And it doesn't stop there. Check out the rack and pinion system. This is a total game changer, turning rotational motion into straight-line linear motion. It's the secret behind your car's steering. And then you have the helical gear, with its slick, angled teeth. This is like the quiet assassin of the gear world, engaging so smoothly and silently, even at really high speeds. So what's the personality of a gear drive?
Well, it's a compact powerhouse, boasting up to 99% efficiency and a perfectly fixed, precise speed ratio. But all that high performance comes with a price tag. They're expensive to make, they need constant lubrication, and they require a really rigid mounting. You could say they're the Formula One cars of power transmission.
Okay, so we've met our three main players. Now for the really fun part. Let's see how they all team up in a machine we all know and love, the car.
A car's drivetrain is just a beautiful example of these systems working in perfect harmony. It's not just one system doing all the work, but a whole sequence of them. It's like a mechanical relay race, where power gets handed off seamlessly from one component to the next.
So let's follow the power on its journey. It all starts in the engine, of course. Then it flows into the gearbox, where all those little gears do their magic to manage speed and torque. A drive shaft then carries that power to the back of the car, where more gears in the differential send it out to the wheels, and voila, we have motion. It's an incredible symphony of mechanical engineering.
But let's talk hard numbers for a second. How do they really stack up in terms of pure performance? Well, this efficiency showdown tells the whole story. Gears are the undisputed kings, with up to 99% efficiency. Chains are a very close second. And our friend the belt, while still incredibly useful, is the least efficient of the three, mostly because of that potential for friction loss and slip.
So what's the big takeaway here? What's the bottom line? It's that there is no single best drive. It's all about trade-offs. An engineer has to balance everything: cost, noise, the need for precision, and how much power is involved. It's always about choosing the right tool for the right job.
And there you have it. We've just pulled back the curtain on the hidden world of belts, chains, and gears. They're the silent heroes all around us, from the car you drive to the watch on your wrist. So the next time you see something move, take a closer look. What machine